Let's give this problem a try here. We've got, as I read this, the length of a rectangle. Now, right away, I see a rectangle, so I'm going to draw a picture. I'm just going to draw a rectangle here. And then it goes on to say that the length, all right, maybe this is the length and this is the width, but the length is 4 feet shorter than 5 times its width. Now, let's just pause for a second, and maybe remember this, maybe not, but when you see this word here, than, like shorter than, longer than, more than, less than, whatever comes after that word, that's where you start. So what we've got here is this. Here's this dot, 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 like more, less, shorter, longer, and then you get to this word than. Well, whatever comes after that word, that's where you start. I don't know if that yellow is showing up too well, but that's where you start. So as you read this, you're reading along, and then you see shorter than. Okay, there's that word than. Whatever comes after that, in this case, 5 times its width, that's where you start. So where do we start? 5 times the width. So we need to introduce some variables here, a variable. And as I read this, see, I'm starting over here with what? I'm starting with the width. So I'm going to let x equal the width. And that's pretty typical. As you read through a sentence, you have to know where to start. And whatever comes second, that's probably what you're going to let x equal. Not 100% of the time, depending on the wording, but almost always it works. So as I read that, the length comes first, the width comes second. So what I'm going to do here is I'm going to let x be the width, and then I can get the length by knowing how to read this business here. And what this tells us is that, right, the length is 4 feet shorter than, now there's that than, so here's where I start here. And just write what you read, 5 times the width. Now the width is x, so 5 times the width is 5x, right, 5 times the width, but then it also says it's 4 feet shorter. So 4 feet shorter, so we have to subtract a 4. So now I've got the length and the width. And now let's move on. So we're told that the area is 33. So if I write that, I'll write this, right? The area is 33, but what do we have here? This is a rectangle. And I know the area formula for a rectangle is length times width, so that's equal to 33. Now I'm going to do is I'm just going to bring this straight down. Here's what I know. The area is 33. I know this fact. Area is length times width. That's 33. But what's the length times the width? Well, in our case, it's going to be 5x minus 4 times x. That's 33. Let's multiply through. We will get 5x squared minus 4x equals 33. Now, this is quadratic, and we know how to solve quadratics. Everything on one side, 0 on the other. So I think what I'm going to do here is I'm going to subtract 33. So I'm going to get this. 5x squared minus 4x minus 33 equals 0. Now, this is quadratic, right? This equation is a quadratic equation. We know how to solve quadratics. We get everything on one side, 0 on the other, and then we factor. Now, I'm going to do this up here. So I'm going to try to factor this left side here. Don't forget to equal 0. Now, 5x squared, only one way to get the 5x squared, a 5x and an x. And then I've got to look for this 33. Now, a 33 I can either get with a 3 and an 11 or a 33 and 1. Now, I don't think, I'm going to try the pair closest together. I'm going to try 3 and 11. Now, where do I put the 3 and the 11? Well, if I put the 11 over here, I'm already up to 55. That's not going to go very well. So I'm going to erase that and try instead here. I'll put the 3 here and the 11 here. Now, any chance here? Here's a 15 and an 11. 15, 11, I can get that 4 out of that. So I think we're okay here. I just need to get the right signs. So we've got 2 solutions to this equation here. We've got this one here and this one. Now, both these numbers solve the equation, but this number here, that is not going to solve our original problem, because what is x? If you follow it all the way back, right, follow it all the way back through all our work, x is the width of a rectangle, and we can't have a negative number here. So we're going to say x is 3. So what we've got now is that x is 3, and then what is x? X is the width. We need the length. Now the length is right here below it. Is right here below it. So I'm going to write it right there, right below it. So 5x minus 4 equals, and there's x right there. So I get 5 times 3 minus 4. I get 15 minus 4. There's the 11. So if we just summarize our results now, what we've got is that the length is 11 feet and the width is 3 feet. This is a work problem here in number 19. So we've got person A now working alone. Person A can do the job in 8 hours, and person B can do the same job working alone in 6 hours. So if you put them both together, how long is it going to take these two people to complete this job? We've got a work problem here in number 19. We got this person A, and person A can complete this job in 8 hours. Person B, working alone, can complete the same job in 6 hours, and what we want to know is if they work together, like put them together here, how long is it going to take them to complete this job? Well, we know this for sure. Person A takes 8 hours. Person B takes 6 hours. So if they work together, it should be less than 6 hours. Now, here's the way I think about this. Here's person A. Now, person A can complete that whole job in 8 hours. So in 1 hour, what fraction of the job can A complete? 1/8. Now B can complete the whole job in, 6 hours. So in 1 hour, B can complete just 1/6 of the job. Then if you put them both together, it takes them, we don't know, let's call it, how long does it take them? We don't know, call it X. It takes them X hours. This is together, A and B together. It takes X hours. So in 1 hour, they complete 1/x. Sounds odd, but it's 1/x of the job. Does it make sense? Because in 8 hours, in 1 hour, 1/8 of the job. 6 hours, in 1 hour, it's 1/6 of the job. In X hours, it's 1/x of the job. So what we're going to get here now is this. Here's A's part in 1 hour. 1/8 of the job can be completed by A. Getting help, so plus, from B, 1/6 of the job. And then this is equal to just putting them both together, equal to 1 over x. So now we've got a rational equation. We know how to solve these. We'll get the LCD. So I'm thinking the LCD here is, now the smallest number that I see that 8 and 6 divide into is 24. And then we've got that x over here. Don't forget the x. Now 6 times 8 is 48. You could use 48 here also. It just keeps the numbers a little bit bigger. So I'm going to multiply all 3 terms by 24x, by that LCD. So put this LCD alongside each one of the originals, and it will look like this. 24x dot 1 over 8 plus 24x dot 1 over 6 equals 24x dot 1 over x. And this gives us 8 and 24 will go 3, so we're left with 3x times 1, which is 3x, plus 6 and 24 will go 4 times, so now we're left with 4 times x times 1, which is 4x, equals, these x's cancel, and we get 24 times 1 is 24. On this side, we'll get 7x is 24, and dividing, I'll do it right here, we'll get x is 24 over 7. But because this is an applied problem, I'm not going to leave it like this. I'm going to leave it rather as this is an improper fraction. I'll make it a mixed number. 7 will go into 24. Well, that'll be 3 times, right? That's 21. And 3/7 left over. And we're talking about hours. So how long does it take them working together? It takes them 3 3/7 hours. That's almost a half hour. So right around 3.5 hours. Now, just as a note, I'm going to write the answer like this. I'm not going to write it like this. I'm not going to say, here's the answer. X equals 3 3/7. I don't want to write it like this because we're being asked, how long does it take? I'm not going to say X equals. I'm just going to say the number.